All right, you are looking at taking the moles to moles quiz, and so this video is for you. What have you already passed? You've already passed balancing equations. Most recently, you've passed just the moles quiz. So from these two things, you should know these concepts. That the conservation of mass says you can't create or destroy atoms. So that's kind of why we're balancing equations in the first place. And that the mole is just a counting unit, although it's a pretty big one. So even though I overuse this equation, I'm going to do it again. It says that two H2s combine with one O2 to make two H2Os. So when I have thought about this previously, this H2 thing, what I'm thinking of is I'm thinking of it as just one particle. And I'm thinking of an O2 the same way, it's a particle. And then I'm thinking of H2O also as just a particle. So that's probably how you're thinking of it too. So if you think of it as a particle, that kind of explains, I'd like to balance this, and I'd like to just stick a little 2 here, and then I'm done, right? I've got 2, 2, 2, 2. But you can't just stick in a little 2 right here, because then you've got something else. You don't have water anymore. You've got hydrogen peroxide, and that's not what this equation is all about. But what I want to do is I want to switch to another unit to describe this equation, and that is the mole. But before I do the mole, what I want to do is I want to kind of ease you into it by thinking about dozens first. So if I were to write this out, if I were to write this reaction out as a sentence, and if I were going to use dozens instead of just thinking about particles, this is what the sentence would look like. So here it is as a sentence. This 2 right here, you got 2 dozen hydrogen molecules, and then your plus, that's the and then you've got 1 dozen oxygen molecules, and they produce, that's the arrow, and then your 2 dozen water molecules. So before we were thinking of each of these things as just a particle, but now if we look at the coefficient differently, if we think of the coefficient as dozens, then that makes a change for us. What's the change? Well, before, when we balanced the equations, I was always telling you, you can't use fractions for your coefficients. Like you couldn't put half here if you wanted to. You couldn't do that because that would be something other than O2. That would just be one oxygen atom, and that's a different chemical. But now that I'm thinking in terms of dozens, now I can use fractions. Let me explain. So let's just say that I did want to put a half right here. If I could put a half there, that would mean that I'd have a 1 here and a 1 here, because remember I had 2, 1, 2. So if I just cut them all in half, now I've got 1, 1/2, and 1. And now that I'm thinking about dozen, now it actually works. Let me write another sentence like this one, and we'll see if it makes sense. So here it is this time. What it says 1 dozen H2s, and that's this, and a half dozen O2s right here makes 1 dozen H2Os, and that's right here. So this sentence actually does work. In fact, it's so easy, I could just go back up into this sentence right here, and wherever I wrote dozen, I could just scribble that out, and I could put in the word moles. So let's read it now. Ooh, I shouldn't have put an S there, should I? 1 mole of H2, that's right here, and a half a mole of O2, that's right here, makes 1 mole of H2O. So that's it. That's the essence of understanding switching from moles to moles. So I'm at 4:15. Now what I need to do is I need to show you what the quiz is going to be like. So the quiz is going to be like this. You might run across a problem that says 7 moles of H2, and then I'll ask you something like this. I'll say, how many moles of oxygen do you need to react with that? Or I might ask you, how many moles of water will you get? So to solve this problem, maybe you already know the answer, but let me show you how I do it. What I do is I set up a proportion. I know that in the balanced equation, this is a 2 to 1 to 2 ratio for this balanced equation. So all I do is I use these to make a fraction, and I use these to make a fraction, and I just solve for the unknown, like this. I'm going to go 2 over 7, that comes from there, and I'm going to say that equals 1 over x, and that comes from there. So you've done stuff like this before. 7 times 1 equals 2 times x. So what do we have then? We have 7 equals 2x. If we divide both sides by 2, we wind up with 3.5. So if I were to say on a quiz, 7 moles of H2, if you have 7 moles of H2, how many moles of oxygen do you need to react with it? Your answer would be 3.5. Now, since you already knew that this was a 2-to-1 relationship, maybe you just were like, oh my gosh, that's so easy, that's just 3.5. But there will be other questions where I give you other numbers, like maybe what if it was like 8.7? Then you're probably going to want to carry out this proportion thing and get your answer that way. So that's what the moles to moles quiz is like. Easy for me to say. And just for the heck of it, since I've got it written here, and I'll keep this under 7 minutes, I promise, or I almost promise. What would my answer have been right here? What would this have been? How many moles of water would I produce? Well, you can do this without doing much work at all, because 2 to 2, these numbers are the same. So that means if you had 7 of these, you must get 7 of those. So that's pretty simple. You could also have set it up as a proportion, 2 over 7 equals 2 over x. Well, the x has got to be 7, right? So that's it. That's the kind of stuff you can look forward to on the moles to moles quiz.